Good morning. All right. So the past couple of days, we have looked at problems where not every piece, if you could see it, not every piece of the equation has a log attached to it. So notice the 2 is all by its lonesome. It is just a plain old number. Okay. Today, the problems we're going to look at is where every single piece has a logarithm attached to it. Okay. So, if I look back at our 2 ways of solving, when every single piece has a logarithm attached to it, like this one, and it's a log equal a log, then we can set their arguments equal to each other. Okay? So, let's go ahead and do this warm up. So, we have a log equal a log, and the bases are the same. So, that means we can set their arguments equal to each other. So, I can set x minus 2 equal to 5. And then solve it, add 2 to both sides. I'm going to get x equals 7 for a possible solution. Again, though, I need to plug it in and check to make sure that arguments are going to stay positive. So 7 minus 2 is 5, which is a positive number. So I'm okay with this as a solution. So again, notice every single piece has a log. And once a log equals a log, we can set the arguments equal to each other. All right, so let's get to that harder stuff, right? Let's look at this problem right here. Again, I want you to notice that every single piece has a log attached to it, but it's not a log equal a log up here. So, similar to yesterday, we need to make it so a log equals a log. So we're going to go ahead and just like yesterday, we're going to condense this into one expression. And again, remember our properties. We know addition within logs really means we are multiplying the arguments together. So I'm going to go ahead and use this property to rewrite the left hand of my equation there. So again, we really know addition within 2 logs really means multiplication. So this is really like we're multiplying 2 times 3x minus 2. So be careful here because I'm going to have to FOIL or distribute. I like distribute better. That 2 into those parentheses. So I'm going to rewrite that. So this is going to become a 6x minus 4. And now notice we have a log equal a log, just like what we had in the warm-up. And since my bases are the same, I can now set our arguments equal to each other. So it looks like I'm going to add 4 to both sides and then divide both sides by 6. I, of course, need to check that to make sure that my argument stays positive. So if I go ahead and plug 2 in for x here, I'm going to get 6 minus 2, which is 4. And last time I checked, 4 is a positive number, so we are okay with x equals 2 for a solution. All right, so let's go ahead and do another one. Again, I want to point out to you that every single piece of this has a log attached to it. So again, first thing I need to do is condense this into one expression so that I can have a log equal a log. And again, our properties say that when we are adding 2 logs together, that really means we are multiplying their arguments together. So I'm going to rewrite this using multiplication. So I'm multiplying the 2 arguments together. And again, I need to be super careful. since this is being multiplied together, I need to make sure that x gets distributed to both of those pieces. So this is going to become a 4x minus x squared. And now I have a log equal a log. The bases are the same, so I can go ahead and set my arguments equal to each other. And it looks like I have a quadratic. I have an exponent of a 2 there. So I'm going to go ahead and have to get this set equal to 0. And right now, since this is negative, I think I'm going to actually move both of these pieces to the other side. So over here, these are going to 0 out. So I'm going to be left with an x squared minus 3x, if I rewrite that in standard form. And now I'm going to go ahead and factor that. It actually looks like I have a GCF. So I'm going to take that out first. So I have a GCF of an x. And when I take that x out, I'm left with x minus 3. And now I can set both of those pieces equal to 0 and solve. So I'm going to have x equals 0 and x equals positive 3. All right, now of course I need to go ahead and plug both these in. So I'm going to actually start with a 3. So when I plug in 3 for x here, we're good, we're positive. When we plug 3 in for x here, we get I should be plugging it into the very original. 3 in for x up here, we're going to get a 1 and a 3. And all of those arguments are positive, so we are good with 3 being a solution. 0. Let's go ahead and plug that in. Remember our rules, I always say it can't be negative, but it also can't be 0 either. It has to be a positive argument. And obviously when I plug 0 in here, I get 0, and we cannot have that. So x equals 0 is not a viable solution. Again, our arguments have to always be a positive number. So that's not going to work. So our only solution here is positive 3. All right, let's do one more. All right, again, notice that I have a log in front of every single thing here. So first thing again I want to do is get it so it's a log equal a log. So I need to condense this into one expression. And again, remember subtraction really means division. So I'm going to rewrite this so that I have division within my arguments. So since this is positive, this is going to be on top, and this is negative, so this is going to be on bottom. And now I have 1 log equal 1 log. So I can set my arguments equal to each other and go ahead and solve. So it looks like I'm going to have to go ahead and multiply both sides by 3x. And let's see, 2 times 3x is going to give us a 6x. And I have to divide both sides by 6 so that I get 3 for a possible answer. And when I go ahead and plug that into my original arguments, notice 3 times 3 is going to give me 9, which they are all positive. So I'm okay with 3 being a solution. One last thing I want to point out. In your homework tonight, you might see something like this. I just totally pulled that out of my butt. So notice where every single piece has a log, but notice in this one, there's a number out in front. We can't condense that when there's a number out in front like that. So if I think back, we only have really focused on these top two properties for solving. But I want to remind you that when we have numbers out in front, when we have multipliers out in front, that's really like that exponent. So another way I could write this is as a log of x squared. Okay? You're going to need that in your homework tonight. So again, numbers out in front are really exponents. All right. Have a good day, guys.